are located here. This is 1 comma 0. This is minus 1 comma 0. Assuming that this is the x-axis and this is the y-axis, positive directions. This is 0 comma 1. This is 0 comma minus 1. If someone makes a table of x and y coordinates like that, in this case, these are very easy, but if you take some other value, then it will be somewhat more difficult. Then one will realize or see that this is actually the equation of the circle whose center is the origin and whose radius is 1. Okay, so this set can be represented like this. This is actually the set of all the points on this circle. Okay, any point on this circle looks like this. So, and that satisfies this equation. And also any ordered pair of real numbers that satisfies this equation lies on the circle. Okay, so unlike many sets, this set has a picture or has a pictorial representation for it. We are asked to show that this circle cannot be written as A cross B, where A and B are subsets of R. Now, if A and B are subsets of R, then there are some sets that can be written as Cartesian products. Okay, for example, let me show it here. X, Y. If I consider this set, what is n? For us, remember, n is the set of natural numbers where 0 is also included. Okay, so here this will consist of all ordered pairs where both the coordinates are natural numbers. So we will have infinitely many elements. This is an infinite set because both the sets are infinite. For example, one element is 0, 0. Then you have 1, 0, 2, 0, 3, 0. It goes like this. Also we have 0, 1, 1, 1. It goes like this. So the set looks like a pattern of some equidistributed, if I use that term, points on the plane. So this set looks like this and it goes on like this. Okay, without any end it goes like this. It's unbounded. However, this set is this circle. So if we are thinking of subsets of R cross R, then they correspond to some pictures or some diagrams. Not Venn diagrams, but some other diagrams which are graph-like. Okay, so this is, you can see that N is a subset of R. So N cross N in this case looks like this. We have to prove that a circle is not like this. I mean, it cannot be written as a product of two subsets of R. This is somewhat more complicated than any of the problems we have encountered so far. We have to show that something is not possible. Okay. So what can we do when we are asked things like this? We have to assume that whatever is said is not true and show that we run into some sort of inconsistency or difficulty, thereby proving that what we have assumed is false. Here we are asked to show that this cannot be written as A cross B, so that A and B are subsets of R. So we assume that. assume or suppose, same thing. Suppose belongs to R cross R such that this is equal to A cross B for some subsets A and B of R. Now we have to run into a contradiction which will prove that our supposition is wrong, thereby proving the result or the claim. So what sort of contradiction can we expect from this? So the first thing we can conclude is that since this set is, see, after writing something like this, what you will do is entirely up to you. It depends on your experience, as I have already said, and it somewhat depends on going down different paths which will lead you to some dead end eventually, until you come across some path that leads you to the solution. So it's a process that is bound to fail at first. Okay, if you don't have any idea what to do, you are bound to fail, but then those failures will make you realize what is the actual thing, what is going on inside the problem, and something may click, then you will see the solution. That is the usual procedure. It's just simply struggling. That's all. So since this set is not equal to empty set, of course it's not empty, it has so many points. 4 points I have already shown. It has infinitely many points, and those points make up the circle centered at the origin having radius 1. That circle has a name. It's called the unit circle. Unit because it has radius 1, but also it has center at the origin. Okay, since this set is non-empty, we have A has to be non-empty and B also has to be non-empty. Because if one of them or both of them are empty, then the Cartesian product is empty. So it cannot be equal to this. So this is the first thing. Why is it the first thing? I cannot say. Because this helps. Somehow I know that this has to be done. Because I want to take elements here. Without first ascertaining that they are non-empty, I cannot take elements in them. Okay. So let A be an element in A and B be an element in B. Okay. Then A comma B must belong to A cross B, and this is equal to the set. You can already see something in this solution, not related to the solution, but something about the writing, that we when we have started this solution, we are having to write this set again and again. Now it's somewhat cumbersome to do so. So what happens in such situations is that in the beginning itself, once we have obtained, here I don't know what is going to happen, okay, I don't really know how the solution will progress. uh, what I mean by that is that I have not sat down and done the solution in advance. I really don't know what I'm going to do after this. But now I am realizing that this set can be given a name. Okay, for example, I can call it C. So we don't have to write it every time. We can just simply write C. Okay, if I call this set C, then I can write C not equal to 0. That is more neat. But anyway, so because A comma B belongs to this, which implies A squared plus B squared is equal to 1, or B squared is equal to 1 minus A squared, or if you try to solve this as an equation in B in terms of A, you will get these two values. Okay, two values or one value, it depends on the value of A. For example, if you have A equal to 1 or minus 1, then this will be 0. So there will be only one B. But at most there can be two B's. Okay, so for a given number A, we have two elements B plus minus root 1 minus A square, right? It helps to think of the diagram also. For example, if I am having A here, then for me, this is one value of B, this is another value of B. A, this is A comma root 1 minus A square, and this is A comma minus root 1 minus A square. Okay, so we have two values here. But if we have A here, okay, that means, if I think of it from the other direction, I take a point here, then that has to be here. Oh yes. See, I have started the solution like this, but after doing so much calculation, now I realize that this is a path that will not lead me to the actual solution, because I have something else in mind. This is how you have to try to solve the problems. You don't really know how to solve them, but if you try to struggle and practice hard, see, practicing does not really mean doing the same thing again and again. That is an entirely different matter altogether. Okay, you try to play some instrument, that you have to practice the same thing again and again, but here you have to just struggle with the concepts. Eventually you will find some solution, and the way you find the solution is totally unique to the problem. Some other problem will have some other obstacles which have to be overcome, but once you keep doing this, this is called practice. Once you keep struggling with the problem, trying to find a solution, the things will click in your mind more, more and more quickly. So that way you will slowly move up in terms of solving problems. Okay, so now what I am trying to, oh, I have, what the hell, this part is, I should not have rubbed this up. This part I need. A cross B for some subsets A comma B of R. This part I need. Okay, I have to arrive at a contradiction. Since instead of considering elements here, I consider an element here. Since 0 comma 1, yes, I can take that one. 0 comma 1 belongs to this. We have 0 comma 1 belongs to A cross B. Yes, I think now I have got the solution. So because this is equal to A cross B and 0 comma 1 we already know, because 0 square plus 1 square is 1. So this point is in this set. So it has to be in A cross B. This implies 0 belongs to A and 1 belongs to B. It is simple because the first coordinate must belong to the first set and the second one must belong to the second set. Right. Similarly, 1 comma 0 also belongs to this set. Okay, which we are not writing, that's why we have written similarly. Similarly, 1 comma 0 belongs to A cross B, which implies 1 belongs to A and 0 belongs to B. Okay? Since 1 belongs to A, you see, here we have 1 belongs to A and 1 belongs to B, we must have 1 comma 1 belonging to A cross B. Because since 1 belongs to both the sets, so it can become the first as well as the second coordinate of an element in this Cartesian product. But then 1 comma 1 belongs to our set This is a contradiction. This is a contradiction because why? This element cannot be here because 1 square plus 1 square is equal to 2, which is not equal to 1. Okay, so we have arrived at a contradiction. That means our supposition is wrong. Hence, our supposition is wrong. what was our supposition? We supposed that this set can be written as a Cartesian product of two subsets of R. So it cannot be written as a Cartesian product of two subsets of R, and that's what we have to show. See, I struggled with this problem, although I have solved it sometime in the past, but I actually forgot the solution. So instead of looking at that, I thought of just attacking the problem as such and see if I can come up with the solution. Okay, so that has to be done sometimes. Okay, so with this, I end the problems of set. There are many different types of problems that you may come across. You try to practice them. But if you look at the problems that we have solved and the identities that we have proved, you will see most of the methods that are used in solving problems like this, exercise problems. And apart from this, if you recall, we are yet to prove some things which we have left. So that will be done in another video. Plus, I also want to show that intuitive set theory is not really enough. If we carelessly use intuitive set theory, there are some extreme situations where the rules of set theory break down. It's somewhat like Newton's law of gravity. It has its own domain of application. I mean, it works well only when the objects you are considering, their speeds are small compared to the speed of light, or they are not very small. If they are moving at high speeds, then Newton's law starts to break down. Also, if they are very small, then Newton's law is not applicable at all. Quantum mechanics is applied there, right? And in the first case, special theory of relativity is used there. So just like that, there are some extreme cases where intuitive set theory fails. The definition of set, which says that a set is a well-defined collection of distinct objects, that is actually not enough. We have to include something else to get rid of a situation which I will show in that video. It is called Russell's paradox. Okay, and that paradox has actually led to the development of axiomatic set theory, which uses some rules, some strict rules to say what collections are sets, not just well-defined collections of distinct objects, but something else. Okay, that is an entirely new thing, and that will be also done, also discussed by us at one point, not now. Okay, so now we are doing all the school level things, but at least in that video, that will be the last part of this video. So where I will at least show that why intuitive set theory is not enough, and then we will rectify that with axiomatic set theory. So with this, I end this part of the video here. Try to collect some set theoretic problems and solve them. If you don't get it, you can discuss with me. Although I am not getting any interaction from the subscribers that I already have. So if you get time, please go through these things and discuss with me. You write in the comment section. And if you are new here, then please subscribe to my channel. It helps me a lot. So with that, I sign off for today. Have a good night.